Welcome back to CXC Physics in Focus. As you know, we've been looking at thermal physics, which, as we said in the last lesson, is the study of heat, how it is produced, how it is transferred, and its effects on matter. In the last lesson, we looked at the mercury in glass thermometer, and we said that when placed in an object which is hot, the mercury rises up the thermometer, and when placed in an object or material that is cold, the mercury falls down the thermometer. This is a very practical example of expansion and contraction. Let us imagine that a microscope can allow us to see the molecules in a substance. We might see something like this. Here, the molecules are moving about slightly because they're at room temperature. Now, let us see what would happen if heat is applied. As you can see, the molecules are moving more quickly and their bonds are becoming strained. If enough heat energy is applied, these bonds will be broken and the matter will change phase. Now, what does it mean to change phase? If enough heat energy is applied to a substance, it changes state because the bonds that hold the molecules together are broken. For example, ice. If enough heat is applied to ice, it melts and becomes a liquid. Remember though, that a certain amount of heat must be applied to the substance in order for it to change phase or state. If this amount of heat is not applied, all that happens is the matter expands. You may notice that on very hot days, telephone wires, for example, sag as the temperature rises. This is because, as heat is applied, the molecules within the wire move rapidly, straining their bonds, causing the wire to expand and therefore sag. As the temperature drops, for example, late in the evening, what happens is the molecules slow down. They don't move that fast. Therefore, the bonds are not as strained and the wire tends to contract, and therefore the wire goes up ever so slightly. This is just one real-world example of expansion and contraction. Another practical example of expansion and contraction is seen in the bimetallic strip. This is a strip composed of two different metals, copper and brass, or steel and brass, for example. They are placed side by side, and when heated, the metal with the highest expansion rate expands more, causing the strip to bend. As the temperature drops and the strip cools, the metal with the highest expansion rate also has the highest contraction rate, and therefore the strip returns to its original shape. The bimetallic strip finds many practical applications, for example, in irons, refrigerators, and in some circuit breakers. When large metal structures are being constructed, they use the principles of expansion and contraction to aid in construction. Whenever a rivet is to be placed in a hole, it is frozen and therefore it contracts. It is placed in the hole, and as its temperature rises, it expands, causing it to fit very perfectly in that particular hole. And this is a common practice in large-scale construction. A practical laboratory example of the principle used in construction is seen with the ball and ring. The ball is able to pass through the ring easily under normal conditions. However, as the ball is heated, it will expand, and as it expands, it will no longer be able to pass through the ring. That's all for this lesson. Remember that expansion occurs as a substance is heated and contraction occurs as a substance cools. Remember also that there are many practical examples of expansion and contraction. For example, utility wires and also bimetallic strips. Look around your house and see if you can find any examples of expansion and contraction in your home, your school, and other surroundings. Until next time, I'm Marvin for CXC Physics in Focus.